Hello everybody and welcome to another Mystery Box Function Challenge. In the purple box is some mystery math and your challenge is to figure out what it is. You can try this by using the link in the description, and when you think you've got an answer, come on back, see if we get the same thing. All right, I'm going to put in a 0. Okay, so 0 gives us -1. How about 1? 0, okay. How about 2? So that gives us 1/3. Okay, how about 3? That gives us 0.5. Huh. So let's try 4. That gives us 0.6. So we definitely have a curve here, and it looks like it's trying to get up to the line y equals 1, but not quite getting there. It's getting a little closer, a little less close each. It increases by less each time we move out. So that seems like maybe it's asymptotic behavior. I didn't get an infinity when I put in 0, so I don't think it's 1 over x, but maybe something in there, something like that, some other kind of rational function. Let's try some other values. I'm going to put in a -1. Oh, okay. So at -1, I get negative infinity. So maybe this is a rational function. This is making me think that it probably is. I want to try some values between 0 and -1. So I'm going to put in -1/2. And how about -3/4? Oops. Okay. Yeah. So this is starting to look like that typical curve, the 1 over x curve, except it's been shifted a little. Um, let's try let's try some more negative values. I'm wondering what happens on the other side of -1, since -1 appears to be, an undefined point on this graph. So let's put in -2 and a -3. Ah, okay. And how about a -4? And -5. Okay, so we're seeing another arm that looks fairly similar to that one. I'm going to try some points between -1 and -2. So -1.5, and maybe -1 3/4. Okay, so I think we have a good shape here, and we can probably do some thinking about this now. So the rational functions, you're used to seeing an arm here in the first quadrant and an arm here in the second quadrant when it's just 1 over x or some slight variations on that. It looks like it's being switched around though. We've got this one that's, I don't know, it's not it's not really in the fourth quadrant here just for a little while, but it's sort of in that area. Like if you shifted the graph down and to the left, that would be in the fourth quadrant, and this would all be in the second quadrant. Um, so something different is going on with this one. Also, it's not approaching the x and the y axes as asymptotes. It's approaching some different places, and I think that's the place to start. So I'm thinking we have a rational function, so I'm just going to put x on the bottom here, but I think there's other stuff going on, so I don't know what to put on the top yet, and I'm leaving some room on the bottom. When you have this sort of two-arm thing in opposite quadrants, I think it's just going to be a plain x and not an x squared. And then what you want to do is you want to look for that asymptote. And to me, it looks like this arm over here is approaching -1, and so is this one. What that means is you would want to make the bottom 0 when x is -1, because that's where the function is going to be undefined here when x is -1. So if x is -1, if I added 1, that would make the bottom 0, blow the whole thing up, and it would be undefined. So that's my guess for the bottom. What is the top going to be, though? Um, I don't think it's some plain number. Let's start looking at some points. So there's a good point. That is the point 1, 0. Here is a good point. that is the point -3, comma 2. And well, this is a good point too, so 0, comma -1. So let's think how we could make all of those points here. So if I put in 0, I'm just going to have 1 on the bottom. So this one would have 1 on the bottom. And what I've got is, is -1. So how do I get -1? So I've got a 0 I'd put in for x. I would have to subtract 1 for it. So if there's an x on the top, it would be x minus 1. Or maybe it's just -1 on the top. Let's see if that works with the other one. So if this is -1, would that work with the point 1, 0? So if I put a 1 on the top on the in for x, no, that would be -1 over 1 plus 1, -1/2. So that doesn't work. So what if it is x minus 1? Would that work for this one? So if it's x minus 1, I'd put in 1 minus 1 and -1, sorry, not -1, 1 plus 1, and I would get, well, 0 over 2, and 0 is what we get out there. Okay, so it works with that one. Let's try this -3, -2. So I'm putting in a -3 for x. So -3 minus 1 over -3 plus 1. -3 minus 1 is -4, and -3 plus 1 is -2. So I'm getting -4 divided by -2. That'd be a +2. Hey, look at that. Okay, so I think we got it. I think this is x minus 1 over x plus 1. Let's go ahead and reveal that. And there it is. Okay, so x minus 1 over x plus 1. Let's graph it as well. And there you see those arms, those two arms you're typically seeing with a first degree rational function. They've just been kind of switched around and shifted a little bit. So looking for their asymptotes is probably the way to do this. And we kind of just trial and errored with these points, but we could have looked at this horizontal asymptote too, and used that as a clue for the number at the top. So this is where the top would become a 0 as well. If you put in 1 here, you get a 0 on the top. All right, well, how did that go for you? I think that was a super hard one. If you got in the ballpark on rational functions, I think you're doing great. Let me know. Thanks, everybody.